Thanks so much, everybody, for coming here. I wasn't sure how many would show up for a topic about data privacy, but I'm super happy so many came. In this talk, I want to share a bit how we went from a company where data was all over the place, basically waiting for a data breach, to having an architecture where it's super safe, super secure, unique, only in one place, and a bit the lessons we learned kind of on the way. But let's maybe start with what we actually do at CarePay. So we already said we're in Kenya, and we started 10 years ago, pivoted a few times, and then ended up optimizing one process, and that is this one here. So this is a picture of a hospital in Kenya, and what you see there is all the insurance claims that the hospital has to send to the insurance to get paid. And if you have a private insurance in Germany, you know exactly the same process. Basically, you go to a hospital, you actually have to pay, you get the invoice, you put the invoice to the insurance, the insurance maybe gets back to you within a month, maybe pays you, maybe not. It's all like super confusing. Kenya has exactly the same problem. And if you wonder why this isn't optimized and digitized in Germany, it's regulation. The great thing in Kenya is less regulation. So we tried to optimize this and basically brought this to a platform that is fully integrated with all the hospitals, integrated with all the insurances, integrated with banks, so that hospitals can get paid within a day and not within a month. And that, of course, makes healthcare cheaper, health insurance cheaper, and allows more people to have health insurance. That's great. The problem is, of course, we collect all kinds of data on the way. Health data, financial data, passports, HIV diagnoses, like things you don't really want to be breached. And we could do this because Kenya 10 years ago didn't have a lot of data privacy regulation. But then about 5 years ago when I joined, they started copying the entire GDPR into their legislation. Our legal team got a bit nervous. And me being the head of data at the time, they were like, Christoph, you do something around data, right? Like, can you like help us become compliant? And me being new in the job, I was very naive. I was like, sure, let's do this. Let me just have a look where we have data in our platform. This is an Excel I dug up from 5 years ago. I just tried to see where in the platform, where in the database do we have personally identifiable information. Turned out everywhere, because somebody had the great idea to use a phone number as a unique identifier for our users. So whenever you see created by and modified by there, that's a phone number. We also had, of course, date of birth, social security numbers, all kinds of stuff. And not just in the database, but also on our Kafka events, in our audit logs, in the data warehouse, ingested all the data, then only anonymized it. As 3 buckets, it was on the laptops of the developers, because, of course, they sometimes needed to debug production. Got a database extract, fixed it, left it on the laptop. Our clients had massive data dumps, because if you work in insurance, maybe you know, but they love big Excels with lots of data. So they asked us to create these buttons on our platform that basically said, download the entire database. Slack messages, I found it on Jira, and I even found it on version control. Let's not talk about the version control part. The problem with this, of course, is it's super difficult to forget somebody, right? GDPR, right to be forgotten, other like laws that have you or force you to expire data after 7 years, after 10 years. If the data is all over the place, that's never going to happen. The biggest problem for us at the time was, how do you actually change a phone number? Yeah? If it's a unique identifier, that's also a problem. And if it's all over the place, even bigger of a problem. And how do you avoid data breaches? Right? Like we had a few small ones. We didn't want the big one. Now, of course, we didn't design the platform like this because we wanted to spread data as far as possible. Right? We designed the platform the same way that this guy designed the electrical wiring of our office in Kenya. You start with something, in our case, a .NET application, and then you add something else, PHP, because we needed a better front end, and then we heard about microservices, we added some microservices, and it kind of grew over time. Data kind of grew over time everywhere, and it was waiting to happen for something like this. This is from 2024, where a very similar company to us, a service provider for medical insurance, got targeted by a hacker, and they lost 33 million records of social security numbers in France. Right? Like, we didn't want to be this company, because when this happens, you're out of business. By the way, this wiring broke down 3 weeks later after we took this picture, and we really didn't want to be this platform. All right. Luckily for us, around the same time that kind of we did all this investigation, somebody approached us and said, hey, what you built in Kenya is a super cool platform. Can you take this and bring this to another country with a lot more legislation and regulation? We'll pay you for it. So this is, of course, what we've been waiting for, because all of a sudden we had a reason and money to move this to a better architecture. But I promise you that what we did here, you can also do if people don't start knocking at your door with a few $1 million to migrate your platform. All right. So what do? We looked at 3 options, basically, to have PII more secure. That's crypto shredding, tokenization, and distributed vaults. You can already see we decided in the end for tokenization, but let me briefly talk about the other 2 parts. Crypto shredding is the idea that you have 1 key per user, and you put this key in a super secure place. You use that key to encrypt all the personal identifiable information in the database. So when somebody hacks the database, there's just like encrypted stuff in there. Whenever you want to access it, you kind of use the key to decrypt it. And then if you want to forget the user, you just throw away the key. It solves the right to be forgotten part. It is still very difficult to manage. It's very difficult to audit. You can't really mask data. It's a bit hacky and crude, but it works. The most beautiful solution, I think, is these distributed vaults. There's a concept out there called Solid. Like, Google it if you want to. Tim Berners-Lee came up with this. And the idea there is that every single user has their own little data vault, where even they could get data in from other platforms. Basically, you are the pure owner of your data. You could even host it yourselves. It's like the most beautiful solution, but it's also the most complex one, the one that was kind of least developed. So when we looked at this like a few years ago, we're like, let's maybe not put all of our money on this, but like I think it's still a great concept. So what we ended up doing is this tokenization concept, and the idea there is you have 1 central part in your platform. You put all the personal data in there. It's fully auditable, like you see whenever somebody wants to access it, and you get tokens in return that you use in all the other microservices. So how does this work? I have 1 little example here. So in this case, Bob comes to our enrollment microservice with his bank account and his name. And the enrollment microservice, just as any other microservice that receives any kind of personally identifiable information, takes the data, sends it to our data vault. In this case, we use Piano, which is like an off-the-shelf system. And the vault returns a token, like something that kind of uniquely identifies the PII, so in this case, the bank account and the name, but it doesn't really say much other than this. And then the service will use this from now on within the entire architecture, right? So you can kind of use this as if it would be data, but if somebody hacks it, it's like all safe. So in this case, the microservice kind of publishes an event, says, hey, I registered a new user. Another service can pick it up, kind of store the token. In our case, the payment microservice stores the bank account number. And then if at some case we need to detokenize this again, for example, because Bob got sick, maybe he got malaria, and he needs to be paid $15 because that's what the claim microservice says. Then at this moment in time, the payment microservice can go to the vault, can say, hey, I need to detokenize the token that I know for this bank account. I need to do this because I need to pay this guy. In the audit log, you always need to put like a reason why you actually need the data. Then you get the value, you give Bob the money, and everybody's happy. Now, usually when I show this, I get 1 question, and that is, why so complicated? Yeah. And usually this has like 2 variations. 1 question is, why do you use all these tokens? And from our perspective, it's super useful because we work in a very distributed setup. Like, we have all these microservices, but we also have integrations with hospitals, integrations with insurance systems, integrations with like some kind of fraud systems. And all these systems want PII. But most of them actually don't need it, right? So they just need some kind of identifier. They need some kind of information. The front ends, I already said, insurance people love personal data, but actually usually they don't need it. So if you give them the tokens instead, most of the time it works, but it's much safer. So you kind of reduce the blast radius. It also allows you to have super fine-grained access, right? If you only pass a specific token around for the bank account instead of an identifier for the entire person, then this payment microservice only has access to the bank account and not the social security number, for example. And there's also like 2 fun variations. So you can either have a deterministic token where you know the same phone number, for example, will always get the same token. So you can use it for like uniqueness checks. But there's also a pointer token variation where you know I will always have the most recent version of this, right? So if you want to change the phone number, you don't have to change all the tokens because the tokens will point to the one that is most recent. The other question is, seems like a pretty simple microservice. Like, why didn't you just build it yourself? Why did you use this off-the-shelf system? Well, we historically, as a company, had the habit of building way too much ourselves. So we tried to do that less. We used Piano in this case because we didn't want to reinvent the wheel, but also because it's actually much more complicated. They are pretty fast, support monitoring, search, masking, access control, like all the stuff we would have to build ourselves. We could run it fully on-premise without like giving anybody access to this data. And we built like a little abstraction layer in between. So in case we ever wanted to do it ourselves, it would be relatively easy to kind of switch it out. Cool. So this is all theory, of course, how it works in theory. The problem is, as you might already guess, like how do you actually roll this out into a company and into an existing microservice landscape? And I think that's something where we could learn a lot from because it didn't go as smoothly as planned for us. I think we started the way that I guess is reasonable. We started with a POC in one microservice. In this case, we took the payments microservice because we said, let's either take one at the very end of our data chain or at the beginning, because if you take one in the middle, then you have like lots of interdependencies. That was pretty successful. They wrote an internal library, this abstraction layer that I talked about. We rolled it out to the full org, but of course the full org at the same time had to implement 100 other features because this client wanted to go us to this other country. Time pressure, lots of Excels with like lots of features that needed to be developed, and it created a lot of chaos. And I think the biggest problem was, while we were supposed to do this, there was still a belief in the organization that GDPR is very annoying, makes everything difficult, and I don't want to have to deal with it. Right? And maybe you've heard of this concept of cognitive dissonance. When you're doing something, but you're believing something else, it doesn't feel so nice. So usually people do 2 things. Either they change what they do, or they change what they believe. Changing what we believe is very hard, so we just changed what we did. Different teams did different implementations. Instead of doing proper authentication, we just had like one master user that was used for all of these vaults. We always detokenized all the data everywhere instead of nicely passing these tokens around. We just returned all the PII to the front end instead of masking it like we could. We didn't really bother with this why string. We just gave a default reason why we needed to detokenize all the time. And whenever the legal team had questions, we kind of avoided them. Now, that sounds super negative, but the great thing is we already set a foundation, right? But if I would do this again, I would invest a lot more time up front in actually working with the teams, making sure everybody understands why we're doing this, because data privacy is super important, and by implementing this, you can actually change the product. You can make sure data is super safe, and everybody can sleep much better at night. To our luck, there was a separate belief also in the organization, and that is that people are a good developer. So eventually, the belief that I'm a good developer clashed with this very shitty implementation. So eventually, we kind of all got together, especially like after most of the stress was done, established best practices, and basically undid everything there, right? So we now detokenize only at the end of the flow. We clean up a lot of the code. And I think the biggest thing that we changed is we used this to challenge the product team and the sales team. Because GDPR is annoying, but if you embrace that it's annoying, if you make it so difficult to access the personal data, then actually that can lead to a lot of changes in the product. Right? So we have a product principle now that we call privacy over practicality. We accept that privacy costs something. It is annoying, but that leads to changes in the product and actually some fun features. And some examples of this is, if you have all the PII data in this vault, you actually can't like search on this. Right? Before, we had all these features where you'd like have type ahead a phone number, and it would show you all the phone numbers of all the users in our platform. Same for names, same for other stuff. It's like very easy to use. It's terrible from a privacy perspective, right? Now, that's just not possible anymore, because it's technically not possible, right? Same for PII. As I said before, insurances love to have Excels with like lots of PII data in there. Our data warehouse just doesn't have PII anymore. It only has tokens. So when they now ask us for something, we're like, sorry, not possible. But maybe have you thought about it doing like this? Because actually you don't need the name of the person, right? And this led to a lot of discussions with our clients. And eventually most of them, we made some exceptions for now, but most of them can like perfectly work without any PII in their reports for their analytics and so on. This is kind of where we are right now, but we also want to build on this even more to kind of embrace the zero trust architecture even more, to like have even more fine-grained access control, masked data in the front end everywhere by default, which this library does very easily. We basically just have to switch our PIIs to return masked data by default and not the fully detokenized data, and use integrations with tokens. All right. So I showed you basically we had a situation where everything was terrible, right? We had PII all over. Now it's only in the vault. Data can now be scheduled for deletion, right? When it comes in, we can just say after 7 years, delete it. Our clients accept non-PII reports. Everything is fully tokenized. Data warehouse fully anonymized. It's amazing. I can sleep at night. If you are like similarly excited than me about this, and you want to get started, there's one thing I can point you to, and that is the company that we work with, Piano, on this. They recently released a new tool. By the way, this is not sponsored by them. They're just like really cool guys. It's called Piano Flows, and what that does is it automates the entire thing I did at the beginning. It just goes through all of your code and shows you where do you leak PII, right? Where in your logs do you have PII? Where does it go into the database? Where you have it somewhere else? And that saves you all the time at the beginning. All right, you can, of course, also connect with me, and happy to take questions. Thanks.